Hello, everyone. Thanks for joining this session. I'm José Ginjo. I'm a success engineer at CELUS. And today we are creating a prototype using an STM32 for KiCad using CELUS Design Platform. So we can kick off this session. With me, by the way, I have Luis and Carolina. They are both my colleagues. They are also success engineers. They will help me on answering your questions at the end if needed. So yeah, let's kick off this session. And on this webinar, we will be talking about prototyping and proof of concept and why it is so important. We will take a look on the project that we will build during our live session. And we will do a recap before a Q&A session, okay? So let's start by asking why. Sorry. Oops, I misclicked. I want you to raise questions on the Q&A panel. There's a Q&A panel on this Zoom call where you can speak up. You can give your feedback about our platform. By the way, it's app.celus.io. I wrote it down on the chat so you can easily find it. At the end on the Q&A session, I want to answer your questions, and that's why it is here, okay? Let's start by asking why prototyping is so important and what it is really. So prototyping is the process of creating a simplified model or a version of your product. It helps making tests and validations on early stages, identifying flaws, design flaws and challenges, okay? Enhances communication among stakeholders because it shows the possibility of making an idea tangible to develop a product, okay? And of course, it's cost effective because it prevents mistakes in later stages of development, okay? So it's very important to always be prototyping. And I'm going to show you some cases I did on my career. So these are photos of my own. And these are the types of prototypes. So this prototype is using a breadboard. So it's a low fidelity sketch, let's say. We can use testing mockup. So in this case, I used the proto board with some switches connected to an existing board. So I can test that board because I didn't know what was exactly there. So this is how we can use prototypes, okay? And of course, high fidelity interactive models, let's say using a development board. In this case, I was using an Arduino. All these three photos were my experience. It's part of my experience. I used all the types of prototypes. But of course, we want to achieve something like this. So this is a prototype I made to test the Raspberry CM4. This is an unpopulated board, but this is a prototype. This is a dev board I developed because this will help me on the future projects that I would use some kind of features or some kind of components that I prepare this board to do. And of course, this is much better than the other three options that you saw. This is a prototype. This is you can do with it. You can do a proof of concept of your product. I mean. So with this being said, this is what we are going to build on this session. So I will show you the project. So let's talk about functionalities. So a dev board or a prototype should have, of course, power, especially if it is a power grid, which is very important because you can test different power supplies. Control, so let's say a microcontroller or some kind of CPU, let's say. Human machine interface, so the user can interact with the product. Communication is very important. It can be wired, wireless. On wireless, you can have a Wi-Fi or Bluetooth, which is very important to test as well. Data logging, because this is something that you need for logging status of different sensors or even actuators. So, and that's what you also need. So we also need actuators and sensors because we want to read the environment and act on it. And finally, expandability, because we want to use this board to test other boards or to make a stackable project, let's say. Okay, so with this being said, we can go to app.celus.io to CELUS Design Platform and design this prototype. Okay, so what we just described, this is what we are going to do. So I'm opening right now CELUS Design Platform, and this is it. So this is at app.celus.io, where you can click it, and you can see here, raise your hand if you are seeing Kubot, because it's our mascot, it's our helper here. So can you raise your hand? Thank you. So this one is Kubot, and it is welcoming us to the CELUS Design Platform, and it's also helping us to learn how to use CELUS Design Platform, or giving you articles to read. So if you want to learn more about CELUS, and if you want to learn a little bit more how to work with it, you can click on those buttons on the top right, so you can learn. These are my recent projects, and these are featured projects, which are very important if you want to have a different way to start, let's say, or if you want to get the value of CELUS Design Platform. Okay, so let's start by creating a new project. Let's create our prototype, and by clicking on create a new project, I'm starting to setting up my project. Okay, so we are starting on the description, and this is already part of our documentation. We can write a lot of things here, and I have some pre-prepared text to add here, but I won't complete it all. I'm gonna copy and paste, so this takes some time. But in the meantime, I will kick off this poll for you, because I think it's some time consuming for me to write down this, so you can also write down your thoughts. Okay, so but this is basically, I'm not gonna populate everything here, but this is where you can describe your project. Okay, this is where you can start by describing your project on a document, because on the end, CELUS Design Platform provides you a PDF, a document. It's your first draft of document for your project, which is very good. I will show you later, because we're doing the whole process, of course. So let's say this project aims to create a versatile prototyping board for embedded systems. It will feature power distribution, STM32 control, human-machine interface, communication protocols, data logging, actuator control, sensor inputs, and expandability. It should enable seamless user interaction and testing of various components, and other things that I will skip for now. But the important thing to mention here is we will use STM32, and that's how I will explain you that you can choose which STM you are using by using our platform. Okay, so we hit save and we go to the project information. This is where you can name your project. Let's say we can name it dev prototype board. This is our board, let's say, and we can populate the functionalities we just speak on the slides, on like few slides before. We can add them here. So let's say we need power, we need a microcontroller. We also see a micro SD here, so let's add it. We have measurement and sensing. We have human-machine interface. You see the idea. So this is for documentation, by the way. This is to complete your documentation. It's not what demands on your project. Of course, this is very useful information for your project, but it's not. It's for documentation. On the other side, the application, you need it because it will filter the templates that we will see. And this is very important because you need to show where your project is shining. So on this case, this is prototyping and proof of concept. So this is the application we are going for. And remember, on the beginning of this webinar, we said that it is a STM32 prototype for KiCad. Of course, we can use it for Altim and Eagle, but let's select KiCad as our EDA tool of election. And for the bond type, you can select from flat to consolidated. I will leave it as flat to see component by component on the list of components of a bill of material, let's say. There are more optional information that you can add. I will skip it for now. So I hit save, and here it's the project specification where we can decide different prioritizations on the solutions depending on the preferred or excluded parts and manufacturers. Okay, so for this case, I will go with STM, so ST Microelectronics as my preferred manufacturer because I didn't decide yet which one of the microcontrollers I want. I know that I want a STM32, but I'm not sure if I want to go to F0 family, F4. So let's see what CELUS Design Platform has to give us and see how it goes. How can we select them? So the power budget and compliance and power temperature, they are optional. I'm not gonna bother that much with it right now, but I will select the template. So this has to do completely with the application we have. If we don't want to use this application, if you by mistake click on prototyping on proof of concept, you can go back and change it. On this case, we have some templates that we can start with. This is like an head start of instead of starting from scratch. We can start with a blank canvas, of course, but why not starting with, let's say, a generic MCO, minimum viable board? That's what I'm going to select because this will have already some functionalities that we already spoke about. Okay. And I ended pull because I forgot. Okay, so this is the design canvas. You can see some blocks here. These are called functional blocks, and they are connected with interfaces or ports. And this is basically our project architecture, and that's what we need to build in order to have all the functionalities we spoke before on this project. Okay, we have already some. We have microcontroller, we have a tactical push button, we have an LED, a power converter, and the USB connector. So we have something here already. We need to expand it. Okay, how can we do it? We can go to the design library and search for the right kubos, the right functional blocks. Okay, so let's say I want a temperature sensor. I will place it here. I want a light sensor, ambient light sensor. And right here, I want a micro SD. Remember the data logging? I will place it right here. And by the way, you can click on the functional blocks and make it bigger, smaller. You can move them around. You can do a lot of things, of course. I will make this bigger because I like to have my main components. So let's say this is a microcontroller based board. So I will make it bigger because of course I will need to make a lot of connections here. I want to have Bluetooth on this board. So I will place it here. And let's say I want some load switches. Okay. So 2 load switches, let's say, and let's place it like this and like that. Like this. Okay. So what we need to do now, we need to connect them to the project. And by the way, I forgot the connectors because remember expandability. And I want to make this big because we might connect some different connections here. Okay, so I will place it here. Now we need to connect the functional blocks to the project, the ones we just added. So let's add. You click on the functional block, and we have plus buttons on all the sides of the square of the rectangle in this case of the block. So let's create one connection node here and another on the load switch, for example. So we can connect them and we can drag and drop this. We can move it, by the way, to make it prettier. We right mouse click, manage settings, and we can select one of these interfaces. In this case, this is a load switch, so I will select it as a GPIO. Okay, I will click to show label link so you can see it here. Okay, so we need to do this for every single functional block. So on load switch, I want to connect another GPIO. So let's go with GPIO. And for micro SD, we need to connect. Oops, I forgot to add it here. For micro SD, we need to add two connections to the microcontroller. So we need to add a GPIO for chip select and one for SPI, because I want this to be connected as SPI. And that's why I'm connecting two interfaces here. Okay. So let's connect everything. Okay, cool. Now I want to connect the temperature, ambient light, and Bluetooth. I want to be those three components. I want them to be connected as I2C, and I want only one I2C channel. How can I do that? I can click on here to add one connection, and then I will create 3 connection nodes here. What I will do is to connect the first block, so the temperature sensor. I will define it as I2C. So I2C, where it is here. And now you can see this arrow here, which means I can extend the connection to other blocks. So I will connect it to the ambient light and to the Bluetooth. Okay. Okay. Now the generic connectors. This is personal use. Okay. So I want my board to have some external connections because I want some expandability. So let's say I want to have on this specific board, I want to have SPI, I2C, and 4 GPIOs for external use. So let's add, so 1 SPI, 4 GPIOs, and then I2C. And I can just bring, for example, this SPI connection and connect it here. So right now, what we are telling CELUS Design Platform is to have a connection, an external connection of I2C, SPI, I mean. So let's add the 4 GPIOs, and let's say we want this to connect here, this to connect there, this to connect there, and this to connect there. And by the way, never forget to select as a GPIO, because this is very important. And GPIO, manage settings, GPIO. And of course, we need to connect the I2C to the generic connectors. We are missing only one thing, okay? We need to connect power to everything. So we have this power line here that comes from the power converter. I don't need to know if it's 3v3 or 5. Okay, I can define it, but the CELUS Design Platform will do it for me, because the solutions we have inside of these functional blocks will differ on the connection we are making. So I will connect power to every single functional block because we need that power. So I will add these connection nodes to the other side, and this is only for organization, of course, because I want to organize it better. So I want to make it this like this. Oops. And I click on the plus button, I connect it here, and then again on the not plus button, the arrow button, and connect it here. Okay, this is not looking very good right now, but don't worry too much. Let's connect the temperature, the ambient light sensor, and the Bluetooth. And of course, we need to connect still, because I forgot, the generic connectors. So this generic connector, it's bringing out I2C, SPI, 4 GPIOs, and the supply. So we can connect other devices here, so we can test. So you can make a proof of concept of your next project. So you can reuse this board that we are making. And this is the best way to do it. It's to create a prototype instead of using breadboards because it lacks of a lot of errors that you can, or mistakes that you can avoid using a prototype board. Okay. So I will click on the magic button, which is resolve, and resolve means search for cubos, which means solutions. We call the solutions cubos. We will see what is a solution exactly, what is a cubo exactly. But CELUS Design Platform will look, I will click, will look for the best solutions for is answering the questions I just made. So for example, I'm asking for a micro SD card that can connect via SPI, or I'm asking for a Bluetooth device that connects via I2C and has a supply equal to this one, which I don't know which one it is, but the CELUS Design Platform right now is matching every single connection I made to get what I really want. Okay, so let's say I don't know if you saw, but we had a pop-up showing that the result happened successfully, which means we have some solutions to check. Okay, of course we can finalize our project already. We can go directly to bomb preview, output files, and download, but that's not what we want to do because we are the ones designing the project, which means it's never a good idea to leave someone make things for you. Okay, so it's like CELUS Design Platform is suggesting some solutions for you, but that doesn't mean that you need to, by the way, sorry, that you need to go with them. Okay, so let's select the right components that we want to use to our platform, the right solutions. And for that, we right mouse click on the functional block that, let's say, on this case, I want a microcontroller, and let's go to select Cubo. And this is a part of a schematic. This is the microcontroller. Okay. On this case, it is the STM32 F103RCT6. And as you can see, it's recommended because I selected an ST Microelectronics as my reference manufacturers. And I have, in this case, I have 5 of them here that I can choose, and they fit my project. Okay. We might have more STM32 microcontrollers, but these ones fit my project. So what I designed on the system architecture. So let's say I'm not sure which one I should select. We can select this one, or you can, let's say, click here to view the Cubo. And by clicking to view the Cubo, you see exactly what's inside this microcontroller, this STM32 F405RGT6. So this is the name of the Cubo. Of course, this is the description, the application, and the specifications you usually see on the datasheet. This is the Cubo BOM, which means you have all the components that you can see on this schematic, where you can click and zoom, and you have the life cycle of every single component, and you can have a deep view of every single component that it's just two. Okay. Additional resources, if we have some, like a blog post or something around this, in this case we don't have, and ports are the ways to connect this Cubo to the rest of the project. So in this case we have 43 GPIOs and I2C and 3 SPIs supplies. So of course it fits our project. Okay, let's close this. I want to select this one, so I'll go to select and lock, which means I really want to have STM32 F405RGT6, which, by the way, is the one that we use on STM32 Nucleo. So let's say we want to make our own Nucleo board, right? So I will select this one. Go back to the project, and this is now part of my project, but I need to resolve it again, okay? Because of course we need to generate new files. Every time you change something on the project, of course you need to generate a new files at the end. Okay, we can go, let's say, for the micro SD. Let's say we don't know which one of these we want. We can use our Kubot. Remember Kubot that was welcoming us on the beginning? So here it is. He is here. It's our AI assistant. It can answer questions that we want to ask. So how can I connect the Kubo, let's say 1, because to my project? So for example, you can ask things related to the Kubo itself or the Kubos you are seeing. Okay. So of course, he gave us a big answer. We can connect, for example, as one GPIO, quad SPI, SPI, your supply. We have different ways to connect this. We can select one of those. And of course, we have more information about this. So this is very good to, if you are not sure about which Kubo you are selecting, you can ask Kubot for more information. Or of course, you can go and open Kubo View and see by yourself. Okay, so of course, the ideal thing to do is to go on every single functional block and select the right Kubo, the right solution, so you can be the one deciding your project at the end. So on this case, I will just resolve again because I'm happy with this solution. Let's say this is my proto board. So I think for a proto board, it's enough. Of course, if it's a more specific project with a specific application, more specific, I mean, you will need to check the solutions one by one because, for example, the sensors might be with a better resolution. You might need different power solutions as well. So it's up to you. Of course, right now I'm happy with this, so that's why I'm jumping to the BOM preview. And the BOM preview, you can see already your BOM, your bill of materials, your list of components, and you can see them organized by functional block. So these are the functional blocks we add on our design canvas. And let's say the microcontroller. This is the one that we select, of course, the STM32F405R GT6. And here we have all the components that comes with it. Okay, we can click to check every single one of them. And this, of course, makes our BOM. And on the output files, you can download that BOM, but also a PDF and the project package. I will download all for now. And this takes a little bit of time. That's why I will kick off a poll for you. This is, by the way, the finalizing the live session. Okay, I will show you just the results that also the value that we come with the CELUS Design Platform, and I'm waiting for this to finish. This, of course, takes a little bit of time, and I will show you the PDF first. That's why I'm waiting a little bit more. Okay, so let's open dev board, the dev prototype board file that we just created. This is the file we created for CELUS Design Platform for you. This is the project description we add on the beginning with the functionalities, applications, the preferred manufacturers. We can see the whole design I made for our system architecture and every single Kubo that we selected. Of course, we just selected this one. This is the microcontroller, by the way. But this is the way you can see every single solution. And at the end, the BOM. So this is a good file to showcase to your colleagues about to review this project. Okay. Okay. Wait, I forgot to show you. Okay, so let's open the files I just downloaded. For KiCad, we get the files, the project files on a compressed folder. So we need to unzip it. So let's extract all. Let's extract here. Okay. So we can open KiCad and then open the project, or we can double mouse click on KiCad project file. And this is our I'm on KiCad 8, and I can open the schematic, and you can see that you have all the schematics here of the cubos we selected. Okay, and of course, you can switch to the PCB editor, and here you can see by yourself the components that we are placing. So these are the footprints of the components. Of course, you need to now place them on the right spots for your board, but this is the value we give to you. I hope you enjoyed, and that's the end of the session, of the live session. So let's do a recap about it. And see how important it is to use a prototype. Okay, so a prototype board can guarantee you reliability and stability because it's also the first reflection of your final product. Improvement of integration and compactness, which means space optimization with a much more optimized placement of your components, because if you are testing, you already know where to place them. Professionalism and presentation, because if you're presenting this to your stakeholders or to the ones that are let's say buying your product, of course you're not showing a breadboard, you are showing something with a board, with a prototype board, which is much more professional. Of course, you can avoid possible mistakes by compliance testing and environmental testing. And finally, scalability and flexibility, because it's better for you to build your next projects. Okay, it's giving you a head start for your next project, which is very good. So guys, thank you for showing up. Thanks for participating. It's always a pleasure to give you some knowledge about how to use CELUS Design Platform. And in September, we will have another webinar. It will be announced in the following weeks. So yeah, okay. Thank you and see you next time. Bye-bye.